Hi there. Today we're going to wrap up Chapter 3. This is our last lesson. It's kind of a long chapter. And we're going to talk about the slopes specifically of parallel and perpendicular lines. It's almost like we're tying it all together. Remember, we spent a lot of time talking about parallel and perpendicular lines at the beginning, and then we spent some time doing some algebra stuff. Let's tie that together. So in this particular graph, the question is, are these lines parallel? So you look at them, they're parallel lines because they're not intersecting. But it's you have to be a little bit more careful than that, because I don't know if my picture's just skewed, but it almost looks like they're not exactly parallel. Is there a way to tell for sure? Yep, we use the slope to tell for sure. Let's count the rise and the run. Since it's already graphed, I could do my slope formula, but I'm going to just count my rise and run. So I'm going to start with this first line, line 1 here, and I'm going to go left to right and count my slope. So my rise is actually negative, down 1, 2, 3, 4, 5, 6, 7, 8, 9, down 9, right 1, 2, 3. All right, so the slope of line 1 is down 9, right 3, which actually just simplifies to negative 3. Okay, good. So what's the slope of line 2? I'm going to do the same thing. I'm going to count my rise and my run, go left to right here. So I'm going to start at this point, and I'm going to go down 1, 2, 3, 4, 5, 6, 7, right 1, 2. So the slope of that line is negative 7 over 2. And you know what? That does not reduce to negative 3. Those don't have the same slope. And that's how you tell if the lines are parallel. They would have the exact same slope if they were truly parallel. So they look like they might be, they're not. The slopes have to be equal for the lines to be parallel. Let's use that idea that the slopes of parallel lines have to be the same. Let's use that to do something extra. It says, what's the equation of the line that is parallel to this line? Okay, it's going to be parallel to this, and it goes through this point right here. Okay, when they tell me that it's parallel to this line, all that really means to me is this right here. That is the only thing I'm going to use. If it's going to be parallel, then I know my slope has to be the same. My slope is going to be negative 3. I'm not going to use that negative 5 for anything. Scribble it out so you don't try to use it. Not going to use it. But this point over here is going to be my x and my y. Okay, so now this goes back to yesterday's lesson. I'm going to write the equation of the line. I know the slope. I know a point. This is the thing where you have options. You can do point slope, or you can do slope intercept. I'm going to go ahead and do point slope on this one. Please feel free to do either method. So point slope, remember, looks like this. Y minus y equals m, x minus x. The first y stays put. The second y comes from my point. So it's going to be y minus 8. My slope is negative 3. And then my first x stays put. My second x comes from my point. It's minus negative 1. That'd be plus 1. And then we'll usually clean it up and go ahead and write it in slope-intercept form. Add the 8 to the other side. And I end up with a plus 5 there. There's my equation. All right. When they tell me that it's parallel, I'm just going to pull that slope out of there, and that's all I use that equation for. Okay, so this one is yours. You try this. I can't do all the work. You got to do some today. So pause the video, work through this problem. All right, this is the equation I came up with. I went ahead and did it both ways. It really varies from year to year, from semester to semester, which method I use more. I really kind of go with majority rules for the class, and that changes from year to year. So if you prefer this other method of doing slope intercept, then go for it. I showed you both ways here. You choose what you want. Now, if you agree with me, then let's keep moving. If you disagree with me, then I need you to pause the video and look and see where you might have gone wrong and fix that. Okay, so we talked about parallel. Let's now talk perpendicular. Let's find the slope of these lines here. These lines look like they'd be perpendicular. Let's check that. The slope for line 1. Okay, line 1 is this one here. So I'm going to go left to right. So I'm going to start right here. I'm going to count my rise and my run to get to this point here. So I'm going to go down 1, 2, 3, 4, 5, 6, down 6, right 1, 2, 3, 4. My slope is -6/4, but I would go ahead and reduce that. That would actually reduce to -3/2. Now let's do the same thing for line 2. Line 2 is going to start here and end here. My rise is actually up 1, 2, 3, 4, 5, 6. Up 6. Right 1, 2, 3, 4, 5, 6, 7, 8, 9. So rise 6, run 9. That also reduces to 2/3. Now, notice that one of these slopes, this is definitely not parallel, right? Parallel have the same slope. These do not have the same slope at all. In fact, one of them is negative and one of them is positive. That is always, always, always going to be the case with perpendicular lines because you got one tilting one way, the other tilting the other way. It's always going to be one positive, one negative. But it's more than just that. Do you see that my rise and my run have flipped? My 2 and my 3 flipped here? Okay, that's a perfect example of perpendicular lines. They're going to have opposite slopes. One's negative, one's positive. And they're going to be reciprocals of one another. That's how you know they're going to be perpendicular. So I got this on a slide. Parallel lines have the same slope. So we need to remember that. And then perpendicular lines have opposite reciprocal slopes. Opposite sign and then flip it. And really what that means, and this kind of I think is in your Math Excel homework, the product of the slopes will always equal -1. So I don't know if you want to clutter yours up right here. Maybe you do. Maybe if you look at that previous example, we had a -3/2, I think, wasn't it a -3/2, and then a +2/3. If you multiply those, the product means you multiply them, it's going to equal -6 over +6, which is -1. That will always happen if they're perpendicular. When you multiply their slopes together, you get a -1. So I've got a problem here for you. It's a little bit trickier problem because it's not graphed, but it's good practice for you. What I want you to do is decide if line 3 and line 4 are perpendicular. What I've given you are 2 points for each one of those. So line 3 has these 2 points. You're going to go find the slope. Line 4 has these 2 points. You're going to go find the slope. And then we want to know if they're perpendicular. So looking at your 2 slopes, are they opposite reciprocals? Will they multiply to equal -1? All right, this one's yours. Pause the video. All right, these are the 2 slopes I got. I got the first one to get me a -8 for a slope. I was hoping on the second one that I would have the opposite reciprocal. I did end up with a positive, but I was hoping for a positive 1/8, and I didn't get that. So I'm going to say, nope, not perpendicular. Okay, now this problem says writing the equation of parallel and perpendicular lines. Now we kind of already did that with the parallel lines. Now we're going to try it with the perpendicular lines. You already wrote the equation of the parallel lines. And remember how you grabbed the slope right here? We're doing the same thing. But this time, I don't want my slope to be the same. I want my slope to be the opposite reciprocal because I'm going for perpendicular. So if the slope here is 1/5, the slope I want is -5 because that's the opposite reciprocal. You can put it over 1, but there's no reason to. Scribble out the +2. I'm not going to use it. This is my x, and this is my y. Okay, now I'm going to go through. I'm going to do point slope form. Y minus y equals m, x minus x. Do y minus -4 equals m is -5, and then x minus 15. Pulling in that ordered pair. I'm going to distribute. This actually becomes y plus 4. And 5 times 15 is 75. My goodness, this is getting big. Okay, so y equals, move the 4 to the other side, 71. Good grief. All right, that'd be hard to graph. Now, I'm going to go through the other method real quick here in case that's your preferred method. Again, it just depends on the year which one we do. So I could use this form here, and I put in my -4 and my -5 and my 15, and I'm searching for b. -4 is equal to a -75 plus b. Sorry, that was my phone. Okay. And I end up with a -71 for the b, and I ran out of room, but I would take this slope right here with this b right here, and I would get that same equation right there. Either way. All right, so then you have one that you have to try by yourself, just like I just got done doing, but this one's yours. Use your method of choice. You don't have to do it twice. Pause the video, go do this one. All right, this is my answer. How did you do? Do you match? I showed it both ways, so whichever way you like to do it, check your work. If you match, that's great. Go do your homework. If not, figure out why. All right, good luck.